Welcome to this tutorial. My name is Toklo, but you can simply call me Sir Protocol. In this tutorial, we shall be looking at how to solve problems involving indicial equations. Indicial equations are also called exponential equations. So what are indicial equations? Well, indicial equations are equations which contain variable or unknown quantity as an index or exponent. For instance, 2 exponent x is equal to 4. This is an indicial equation because this equation contains a variable which is x, and this variable is an exponent. So because of that, we say that this equation is indicial equation. So how do we solve a problem like this? To solve a problem like this, we shall be using a law which says that if you have a number, let's say a exponent, another number, let's say m, is equal to a number, let's say a exponent n. I'm just using the variable to represent the numbers, any number. So the law is saying that if the base are the same, then the exponent are equal to each other. Or if the base are the same, then equate the exponent. Therefore, since the base are the same here, it means that the exponent are also equal to each other, provided a is not equal to 0 or 1 or negative 1. Then you can use this law. So let's try some example. Let's say we have an equation like this: 2 exponent x is equal to 2 exponent 2. So if you look at this example carefully, you realize that the base are the same, in this case 2. So because of that, the exponents are equal to each other. Therefore, x is equal to 2. Now, let's try the example that we started with in this tutorial. So we have 2 exponent x is equal to 4. So to solve this problem, you can see that the base are not the same. Note, 4 here is a base. Exponent what? 1. Every number is a base to exponent what? 1. So how can we write this so that they will have the same base? But we know that 4 can be written as what? 2 to the second power. So let's do that. It means that my equation will now become 2 exponent x is equal to 2 exponent 2. So looking at this example carefully, we realize that the base are now the same. Therefore, the exponents are equal to each other. Hence, my x is equal to what? 2. You can cross-check and see if your answer is correct or not. So this is the problem. 2 exponent x is equal to 4. And we say that the value for x is what? 2. So let's substitute the value of x equal to 2 in this to see if you are going to get 4. Okay. So we are going to replace x with what? 2. This means that 2 to the second power, x is now 2. This is the same as 2 times 2, which is equal to 4. So as you can see, the answer we have here is the same as what is here. Clearly, our answer is correct. Let's try the second example. 3 exponent x plus 2 is equal to 9. Pause this video and try to solve the work on your own before you come and have a look at the solution. If you look at this work carefully, you realize that the base are not the same. 3 and 9, they are not the same. So what can you do to make the base to be the same? We know that 9 can be written as 3 exponent 2. Therefore, my equation will now become 3 exponent x plus 2 is equal to 3 to the second power. Now, our base is not the same. That is 3. Therefore, the exponents are also equal to each other. Hence, x plus 2 is equal to 2. In order to get the value of x, we just have to add additive, we just have to subtract each side by what? 2. Or we add additive inverse of 2 to both sides, which is what? Negative 2. Therefore, my equation will now become x plus 2 minus 2 is equal to 2 minus 2. 2 minus 2 is equal to 0. Therefore, my s is equal to 2 minus 2 is equal to 0. Therefore, my s is equal to what? 0. Let's check and see. So my x is now equal to 0. We are going to replace the x by what? 2. By 0 to see if we are going to get 9. Okay. So in place of x, what do you put there? 0. Therefore, I have 3 exponent 0 plus 2. 0 plus 2 is 2. So I have 3 to the second power, which is the same as what? 3 times 3, giving me 9. Hence, what we have here is the same as what we have here. Therefore, which is 9. Therefore, our answer is correct. This is the end of this video. In our next tutorial, we shall be looking at more complex example, and I believe you have learned something today. Okay, so protocol says, have a lovely day. We shall meet again in our next tutorial to learn more. Thank you. Bye.